this lesson, we're looking at the idea behind proof by mathematical induction. So essentially, proof by mathematical induction is a method of proof that is focused on an iterative consideration around natural numbers. So it all depends on an initial proposition specifically about a set of natural numbers n. Now for us, these propositions are going to look at proof of sum formulas and proof of divisibility. And the idea is that we'll be able to prove true for all natural numbers n by doing the following. Okay, so the first thing that we will do is we will show it's true for n equals 1. So it's true for the first number. So that's step 1. Step 2 is we're going to assume that it's true for all natural numbers. So that's where we let n equal k. So k just represents any natural number. And then thirdly, we want to prove that it's true for n is equal to k plus 1. So this is saying that we're trying to prove that it's true for every subsequent number. Okay, so what this really means is by following these 3 steps, show, assume, and prove, if we show it's true for n equals 1, then it's obvious that it's true for 1. Okay, so that should be pretty straightforward. Assuming it's true for all natural numbers, this gives us something to prove. Now the idea is if we prove true for n equals k plus 1, that means if it's true for n equals 1, then it's true for, well, it follows that it's true for n equals 1 plus 1, which is 2, right? Now, if it's true for n equals 2, then it follows that it must be true for n equals 2 plus 1, which is 3. And we can follow that process infinitely. So by using this method of proof by mathematical induction, we can prove that it's true for all natural numbers. So I hope this makes sense. We're going to look at those 2 applications mentioned above, where we're looking at a proof of sum formulas and proof of divisibility in the 2 lessons following this. Okay, so that concludes the lesson on the introduction to proof by mathematical induction.